are we looking at today? We are looking at alkanes. Alright? Can you guys hear me alright? By the way? On chat? Could you tell me? Yep, okay. Okay. So today we're going to look at the first group of compounds in organic chemistry. These are by name called alkanes. Alkanes are what we call hydrocarbons. By definition, we call them saturated hydrocarbons. So alkanes are saturated hydrocarbons. They are compounds of carbon and hydrogen, and we call them saturated. Saturated means that I'll tell you what the means. Saturated means having no carbon-carbon double bonds. They're saying the sound is static. Somebody's saying the sound is static. Okay, here. Okay, let me just do this. All right. Oh, I'll tell you why. Is the sound better now? How is this sound? Loud? Now? Is it fine? It's worse. What about now? Not good? Alright. It's good? Okay, let me try this one now. Sorry, guys. Let me try this one. How is the sound now? The same as before or better? Okay, this is the best of the three sounds. Alright, so we'll continue with this. So, alright. You can hear me well? Alright. So continue. Continuing this idea of saturated hydrocarbons, right? That's what I was saying. So, now let me explain the term saturated. Saturated molecules are one where all the bonds are single covalent bonds. So all bonds are single, meaning not even one double or triple bond. Triple bond. All the bonds are single. So an hydrocarbon, that word means what? A compound of carbon and hydrogen. We mentioned that in the first class also. So now that you've also learned how to name these guys, you probably have come across alkanes. Hydrocarbons. Compound of carbon and hydrogen. Yeah, that's what a hydrocarbon is. It's a compound of carbon and hydrogen. Alright. Now, because the fact that the molecule is saturated, meaning all the bonds are single, it tends to be unreactive. So this guy is an unreactive guy, but we'll talk about that. Compounds, we'll talk about all the members that make up this functional group called an alkane, and we'll be using terms like displayed formulae, homologous series, and I'll mention all of that to you. But what we have is the idea of alkanes. Now I'll show you some alkanes. You've probably seen them already, but I'll paste. These are some alkanes. This is what we call the simplest saturated hydrocarbon with only one carbon atom. Then this is the second simplest hydrocarbon, meaning it has only two carbon atoms. The third simplest hydrocarbon would actually have three carbon atoms. And these are examples of alkanes. And what we're going to look at is, we're going to look at their names, their structure, their physical properties, and their chemical properties so far. Alright. Now, after having studied this, now these are the three simplest ones. What I've drawn here is displayed formulae. If I write all of these guys molecular formulae, the first one is a CH4, the second one happens to be a C2H6, the third one happens to be a C3H8. And so what I want you to do is recognize that C3H8 is what we call a molecular formula, while this is called the displayed formula. So this is called the molecular formula, while this whole thing, which I should not use yellow because I use that for carbon, this whole thing is called a displayed formula that shows the structure of all the bonds, the layout of all the bonds in an atom. So these are the simplest alkanes. I bet you already named them already. This fellow is one carbon, so it's meth, and because it's an alkane it ends in ane. The second one is eth, and it ends in ane. The third one is prop, and it ends in ane. Methane or methane, ethane or ethane, propane or propane, no matter which dialect and accent you use. That's the names. All right. So the simplest hydrocarbons are these. The simplest, saturated hydrocarbons are these. Does that make sense so far? So far so good or no? Understood. All right. Okay. Okay, moving along. The next thing would have to be okay. Okay. Sorry, guys. Just 1 second. Okay, done. ठीक है. Sorry. Now, if I ask you to make an observation between these three fellows, CH4, C2H6, C3H8. If I ask you to do that about alkanes, just take the simplest formula, CH4, C2H6 and C3H8. Now, if I look at the difference between the first and the second fellow in the formula, what extra does this have that this doesn't have? This fellow has one more carbon atom. So ethane has one more carbon atom than methane, but it also has 2 extra hydrogen atoms. So it's like I must have added a CH2 to methane to become ethane. And if I add this, if I look at this fellow and this fellow now, okay, now you got to think of it like Lego, like blocks, like things we add, more so than anything else. It's more like math than anything else. So if I look at the ethane's formula and propane's formula, what does this have more of? What does propane have more of than ethane? So while propane has 3 carbons, ethane has 2 carbons. So it also has an extra carbon atom and 2 extra hydrogen atoms. So ethane has 1 more CH2 than methane, and propane has 1 more CH2 than ethane. And if I were to tell you, the next fellow in this list was butane with C4H10, whose structure I will draw for you. But if you just take my word for it for now, and I tell you that the next simplest alkane we know in this series has C4H10, if I find that fellow's difference with the previous guy, that fellow is called butane. The difference is also of 1 carbon and 2 hydrogens. And now you must realize that there is a constant sequence, like, so you can even predict the next fellow from here. You know, what would be the next fellow from here? What would be the next guy? Can anybody predict that? So if I focus here for a second, what will be the next fellow that comes after, butane? You add an extra CH2, what would you get? C5H12. What's the next one? You add another CH2. Give me the next one. Remember, one H, one carbon and two H's. One carbon and two H's. So what's the next guy? C6H14. Okay, what's the next guy? Give me the next guy. I'm hungry for the next guy. Give me the next guy. It has an extra CH2. What do you make? C7H18. Yep, great. Give me the next guy. Come on, let's do it. Let's do it. The next guy will be what? C8H18. This is what you're predicting the next 9 carbon atom would be. It'll have 9 carbons and 20 hydrogens. Absolutely. And then what? C10H22. Then the next guy, C11H24. You see a pattern developing here, right? Now that means you can count this to infinite numbers of carbon atoms, because you know whatever you have, just add 1 carbon and 2 hydrogens to get the next guy. So literally you can keep on doing this till forever, literally. And because of this, we have come up with a formula that just helps us predict. So whenever you have a constant number series, and you'll do this in math later, you can even come with a general formula. So 2 things to note here. First of all, any series of compounds, which if I were to take my lead from these guys, this series was CH4, then C2H6, then C3H8, then C4H10, then C5H12, then C6H14, then C7H16, then C8H18, and so on. This series may every consecutive member differed by a CH2 group. Yeah. Okay. Now there's a special name given to such series. This isn't the only series, by the way. This is one of the series, but any series that has a difference of CH2 group is called a homologous series. So a homologous series is a series of molecules that where the consecutive members differ by a CH2 group. That's what it means to be a homologous series. Okay. Yeah. Now again, I'm going to teach you a method that will take you more than what you explicitly need to know. Like in terms of numbers of carbons, you went to 11, 12, you can go to 15, you can go to 20, you can go to 35, 50 if you want. The idea is to understand, be able to do that. The names are the first 8 which you need to know. But I'm not talking about the names, I'm showing you a sequence here. Alright? And this is called a homologous series. Any series that differs by a CH2 group. I showed you one here. Now we are still going to talk about alkanes, but if I showed you another series like this, a series called C2H4, C3H6, C4H8, C5H10, C6H12. Let's call this series B. Okay. Then I'll say I'll give you series C. Oh no, series, I hate C's. Let's give you series D. CH3 OH, C2H5 OH, C3H7 OH, C4H9 OH. I give you series E, CH3 CO2, no, HCO2H, CH3 CO2H, C2H5 CO2H. Now what am I giving you series here for? I am giving you 3 different examples of more homologous series. Now how do I know these are homologous series? Because what did you need to be a homologous series? You needed consecutive members to have a difference of a CH2. So where's the CH2 difference here? Well, if you compare C3H6 to C2H4, what difference do you get? A CH2. Between C4H8 and C3H6 is also a CH2. it's also a CH2. It's also a CH2. Now let's compare these fellows. You see this, the first member in this series. Now I'm not even giving the names of what particular series B, C, B, D and E are. I'm just saying this can be categorized as a homologous series. D can also be categorized like a homologous series. What's the difference between the first two members of D? Look, 1 carbon, 2 carbons. So there's an extra carbon here. And this has total of 4 hydrogens. This has a total of 6 hydrogens. 4 hydrogens, 6 hydrogens. That's a difference of 2 H's. The O's stay the same. So here these also members have a difference of a CH2. Between this and this fellow there is a difference of CH2. Between this and this is a CH2. So not just the alkane series, but series B is also homologous series. Series D is also a homologous series. And series E, if you take these two, has 1 carbon, has a total of 2 carbons. And sometimes it's best to write the molecular formula before writing the, this is the molecular formula of this fellow. If I want to write the molecular formula of CH3CO2H, it's C2H4O2. The molecular formula of the third fellow is C3H6O2. Now this is our way of showing a particular functional group we'll talk about later. But all of these three have this molecular formulas. So here their difference is what? 1 C and 2 H's. Their two differences also 1 C and 2 H's. So these are these are all examples of individual homologous series. Now not all organic compounds are a particular homologous series. I am saying that you will be able to see a lot of homologous series as subsections of organic chemistry. Now if you haven't figured this one out, this is the top one, the one in white is the alkane homologous series. Part B is more likely a simplest alkenes homologous series. It's not the only alkene homologous series, but it is one of the alkene homologous series. D is an alcohol homologous series, all right, and E is a carboxylic acid homologous series. Well, if something isn't a homologous series, it's no series at all. That's all. They can be a series of molecules, but they might not be a homologous series. A homologous series specifically is the one that differs by a CH2 group, and any series that can be a homologous series is also can also be represented by what we call a general formula. So anything that is a homologous series can be called a general formula. Now we will look at general formulas in more detail when we look at each individual chapter, but for example, for alkanes the general formula is CnH2n plus 2, this fellow right here. Okay. This general formula can be used to figure out any member in this series. Think about it. Look at this series formula. If you know math, you can even have deduced the formula, but let's say I'm telling you the formula. Okay, this is Noman. If you need to be told what chapter this is, I think you must be studying biology right now. We are doing, I don't know, moles right now. I mean, hello, like this is organic chemistry, Noman. Yeah. For those of you over the first time, you should probably catch up with videos and then come. At least the last 3-4. I know Saad, AS Bio में भी है, AS Chemistry में भी है, A2 Chemistry में भी है. Are you not just having fun at the expense of somebody else? Yeah. Okay. So let me continue. Now if you were to find, let's say I want to know what the 6th member is. you can use a formula to find the sixth member. What that means is you want the N to be 6. If N is 6, using this formula, 2 times 6 plus 2 will get you what? 2 times 6 is 12 plus 2 is 14. And that literally is the formula for the sixth member right there. So anything that's a homologous series can have a general formula, and the general formula will help you determine the formula for any one member of the homologous series. Now the green B row has a formula CnH2n. You'll study this in later with me. These are alkenes. We'll go alkanes right now, but just to introduce you to alkenes right now, that's their formula, and we'll look at that again. What that means is if I want 6 carbons, then it becomes 12 hydrogens. You see that right there? Or 4 carbons and 8 hydrogens right there. So that's the general formula for the alkane series. Alkene series. This D is in fact an alcohol series. It's CnH2n plus 1 OH. CnH2n plus 1 OH, where N is the number of carbon atoms. So we want the third member, then N is 3. So carbon is 3 and hydrogen is 2 times 3 is 6 plus 1 7. C3H7OH. And this series is called the alcohols series. And the last one, E, is actually CnH2n plus 1 CO2H. Now since there is already one carbon here, you realize N can even be 0 for these guys, because if N is 0, then it's HCO2H. If N is 1, is the second compound, because N is 1 means 1 plus, then this is 3, CH3 CO2H. If N is 2, then it is C2 H5 CO2H. That's the third member here, and these are called carboxylic acids. So these are the 4 major functional groups or chapters we'll study. Each of these is one homologous series, meaning consecutive members differ by a CH2 group, and all of these 4 series will have a general formula. This is the general formula that I'm highlighting for an alkane. This is the general formula for an alkene. Then this is the general formula for an alcohol, and lastly is the general formula for carboxylic acids. So 4 different chapters, 4 different homologous series, 4 different functional general formulae. All right, any questions so far? It's been a long rant from me. Anybody? Nope, crystal clear, no questions. Awesome. I must be awesome, aren't I? I'm just kidding. All right, guys, just give me 1 second. Sorry about the delay. I'm back. Where was I? So yeah, next thing. So now let's get back to the alkanes. Now, so let's look at the alkanes again. So the first member is CH4. It's called methane. The second member is C2H6. It's called ethane. The third member is propane. The fourth is butane. propane, butane, and you draw it like this fellow. Yeah, in fact I have them already drawn, so might as well bring them back. Remember, I had drawn them earlier. Yeah, at least the first three, right? So might as well bring them back in the game. This was methane, this was ethane, you know, methane, ethane, and this fellow was propane. And if I just duplicate this fellow and see what I'm going to do, I'm literally just going to delete the H and add an extra carbon and 3 H's. So removing an H but adding 3 H's is like net adding 2 H's. So add a CH2 and the older H again. So now this is the displayed formula. All right, displayed formula, molecular formula, name. And so the next thing we got to talk about is the physical properties, and that's something that, so they all have the same formula, but one thing is that the physical properties mean the boiling points increases. So basically if I say, okay, so the number of carbons in the chain is 1, 2, 3, 4, and I'm going to show you the boiling points. Now you don't need to know the actual temperature, you don't have to learn this, but if I tell you the temperature, you will realize that, okay, they are increasing. So I won't even give you the temperatures, they're all gases, but boiling points increases down this list, which means as the number of carbon atoms increase, I'm telling you the boiling point is increasing. Yeah. So far, any questions so far with this? Now, why does it increase? Okay. Now, why does the van der Waals increase? Well, because, sorry, why does the boiling point increase? Why? Why is the boiling point increasing? Because van der Waals forces become stronger as the chain becomes larger. And why do they become stronger? You are told that because the MR is increasing, the van der Waals forces increase. But MR increasing, and you learned this in A levels, will also mean that because the number of electrons in the molecule are increasing, so hence you have the boiling point increases. So that's something that you got to remember, is that, you know, the boiling point increases. And why does the boiling point increase? Because the van der Waals forces become stronger. And why do van der Waals forces become stronger? Because the MR increases, the number of electrons increase, that kind of stuff. All right. Now, any questions so far? Nope. All clear? Yup. But do note that all of these guys are gases at room temperature. All right. And but if the boiling point increases, yes, their melting point will also increase. That happens in tandem. So the boiling point increases and the melting point also increases. All right. What else? Anybody else? So far so good. Hi Ramesh. What's up Ramesh? How you doing Ramesh? Acha, one more thing. These guys are all, one other thing, they're all colorless gases, and do not dissolve in water. That's important because there are some gases that dissolve in water, but you will realize that alkanes or hydrocarbons will not dissolve in water. It is very useful property that we have for these guys. We use it for multiple things. Yeah, we can use it. I mean, we have this property and then we can use it to our advantage. Like for example, you pass this gas through water to clean it, it won't dissolve in the water. That's the beauty of this. It won't dissolve in the water. It'll just bubble through, and that helps actually just becomes good for us really actually. Yeah, I mean we can use that. It's not perfect, but it helps us to separate them. All right. Maybe I just confuse more people with that information, but don't worry about that too much. You can ignore that. Can we clean sewer water with alkanes? No. Oh, you're sending emojis. Oh, well, send us a nice one, Haya. One that helps us smile. Saad, no, we can't clean them with the no, honey, no, honey, no. I wish we could. I wish. Now, take care. Okay, let's go on. All right. Sir, do you know why alkenes is the Sharif kid of organic chemistry? No, but I bet Saad there's a lame joke coming there. Yeah, there's no Windows on the MacBook. Yeah. Oh my God, Saad. That's so lame. Oh my God. The fact that you know what meth is so sad. Oh, because Saad didn't choose to make it. It's a 200 IQ joke, Saad said. Saad said, why do you know? Do you know why alkenes are the Sharif kids of organic compounds? That's what he wants to know. Okay. Now, Nim on YouTube, there are about 300 A2 videos for chemistry. So I don't tend to do that live. There's already recorded videos there for A2 levels. I'm doing this for O levels. They're behind on my love. Okay, Saad, Mesam, the reason is because alkenes stay away from meth. That's a joke. Yeah. And Cami writes, this is so easy on YouTube, Sir Electrochemistry. I'll say that about electrochemistry. That's so easy. Why do you want electrochemistry? Okay, moving on. Yes, I will do it. I'm just going back to organic O levels right now. Okay, where was I? I was somewhere. Let's look at alkenes' chemical properties. Alkanes. So, alkanes' chemical properties. Now, you need to know this, that alkanes, the saturated hydrocarbons, are generally unreactive. Okay? इनके they don't have many reactions. Oh, Ramesh, good one. Now can we go back to lamer chemistry, from lame jokes to lamer chemistry? Oh my God. I know, Saad. And stop writing to me in panelists only. It's rude. You should write to panelists and attendees. He's writing to panelists only. Saad is proud because he started a joke fiesta. That's exactly what everybody logged in for. Jokes. Yes. Eight. Yeah. You know why my daughter asked me the other day, "Hey dad, can you tell me why everybody's afraid of 7?" I was like, "I don't know why everybody's afraid of 7." She's like, "Because 7, 8, 9." That's the kind of joke that you guys just pulled. Yeah, actually, it's better than a joke. Amino acid, but chalega. I know. Anyways, let's start. They don't have many reactions, and in fact, all the other functional groups, alkenes that we study, alcohols, carboxylic acids, those fellows have more reactions than alkanes. We are only going to be discussing its one reactions. But all organic compounds, even alkanes, undergo combustion. Combustion is a form of oxidation. It's called burning. Combustion is burning in oxygen. And alkanes give off lots of heat on combustion. I'll show you a combustion reaction. I'll show you that is. But because they give off lots of heat, we call anything that gives off a lot of heat on combustion is used as a fuel. Because what's a fuel? A fuel is something that will give us energy. Yeah. So, alkanes are good fuels. Why? Because they burn and give off energy. In fact, if you live in Pakistan, that's how you cook food. You burn the methane gas on your stove, which then gives me carbon dioxide and water, and the reaction is highly exothermic, which means it gives up lots of heat, which means it's a great fuel. Yeah. And this reaction is combustion, and all alkanes and other organic compounds all undergo combustion. This is the simplest alkane, but it is not the only one. C2H6 can burn, C3H8 can burn, C4H10. All of these burn with different amounts of oxygen to form what? They all make carbon dioxide and water. Carbon dioxide and water. Carbon dioxide and water. And you got to balance the carbon dioxide and water. And as many carbons are here in the compound, that's how many carbon dioxides you need you make. And as many hydrogens you have, half as many water molecules you make. So you got 4 H's, you make 2 H2O. I'm just giving you the what do you call it, the ratio, the solving it, balancing it. So 6 hydrogens here really mean 3 waters. A trick to balancing it: 4 waters, 5 waters. C10 will make 5 waters, because that's how you balance the hydrogens. And then you balance the remaining oxygen, because you are using 2 times 2 is 4 plus 3 7 oxygens here, so you want 7 oxygens here. So what do you have? You have 7/2 oxygens, or so known as 3.5. If you go here, this has 2 times 3 6 oxygens plus 4 10 oxygens, so you need 5O2. And here you have 4 2s are 8 and 5 13 oxygens, so this needs 13/2 or 6.5. For those of you who are new to my class, yes, you can use decimals or fractions to balance equations. And now they are all highly exo, it's just that they become even more highly exo. More exo here, even more exo here. very more exo. So you realize that as the number of carbon atoms increase, the energy increases. Now the funny thing is, the petrol in your cars is also an alkane, and diesel is also an alkene. Sorry, excuse me. Petrol is mainly made up of C88H, and let's say diesel is like 12 carbons. I don't know exactly, but yeah. And this is petrol burning. It also makes carbon dioxide and water. And this is diesel 26. Excuse me, I'm having a dry cough. Absolutely, Ramesh, you have exactly hit the nail on the head. The more CH2s you have, the more. What do you call it? Exothermic it is. Yes, sorry, Bob. You can make 8 CO2 and 9 H2O. Excuse me, I don't know what's happening with me, man. Dry cough. Yes, Saad, absolutely, Saad. Exo, this is petrol. And diesel, which is what has even more carbon atoms. If you remember, a larger car uses diesel. A truck uses diesel because they need more energy. So they use diesel to get even more carbon dioxide, even more water, and even more energy. You know, is sorry guys, I'm so sorry. It just comes. So that's why foods के लिए इतनी energy चाहिए, काफ़ी है. But for cars and trucks, you need larger carbons, larger alkanes, so they can give even more energy. All right. And this is alkanes being great fuels. All right. That's the most important property. They are great fuels. Okay, I'll balance it. Fine. Oh my. By the way, guys, you don't have to learn these equations. You can just know that any alkane burns in oxygen to make carbon dioxide and water, and all you do is just balance it, whatever hydrocarbon they give. Now, this one is how many oxygens? 24 plus 13. That's 30. 24 plus 13 is 37. 37 over 2, which is what? 13.5, right? No, 37 is 18.5 O2s. Yeah. So that's how many they need. All right. So far so good. Any questions from everybody here? Hana, Hanan, Abdul Rahman, Arisha, Hamna, Haya, Miral. You guys are quiet. Rida, Noman. No sir, all good. Noma. All right. Now, All right. Ramesh, what the hell, dude? Like, are you showing off that you have a good keyboard? Is that what you're doing? Like, hello? All right, great. Now, that part is fun, but let's focus on this, fellows, for a second. Which ones? Petrol and diesel. Now, one molecule of each, you notice, requires more and more oxygen. Like one molecule of petrol, which is C8H18, requires 12 and a half molecules of oxygen, and it makes a lot of carbon dioxide and a lot of water. But diesel requires even more. I hope this, but by the way, petrol and diesel are mixtures. So petrol has octane plus others also, diesel has this plus others also, but let's just assume that this is diesel. Now, if I were to ask you if you ever seen the exhaust of anything that is petrol versus diesel in the car, remember these are both in cars and trucks and all that. Have you ever noticed the exhaust of petrol versus diesel? The exhaust pipe. Have you noticed something? From the colors of the exhaust gas. Have you ever noticed that the buses and the trucks, at least if you live in Pakistan, because you're not going to get this problem in a modern country like Dubai or Saudi or America. You're going to get this problem in the beautiful land of Pakistan, where if you have a big bus or a truck, especially in Karachi, by the way, it's all over the place, that the big trucks have a lot more black and white smoke, and cars tend to have even colorless smoke most of the time, and sometimes they might have white smoke if it's cold, but it's the buses and trucks that start having white smoke and even black smoke. Have you ever seen a black smoke coming out of a Pakistani bus or a truck or a trawler? Yeah. Now, the reason why that happens is that the buses and trucks use diesel, and diesel requires more oxygen than petrol, and the more oxygen you require to burn, and if you don't get that oxygen properly in your car engines, is when you have that black smoke. That black smoke is in fact what we call incomplete combustion. And what has happened is that the diesel, because of the lack of oxygen, only made carbon and steam. It made 13 molecules of water, it made 12 atoms of carbon, and if I were to look at the oxygen, how many they need? It needs only, this guy only needs 6.5 oxygens. The point being that if there is limited oxygen, then the same diesel will not burn to form carbon dioxide, but it will use less oxygen to make carbon, and that carbon is your black, what we call soot. Okay, this is the black smoke that comes out, and look at the difference. It only needed 6 molecules, 6.5 versus 18.5, and that's what happens. So when you have fewer air supply, when the air supply is decreased, then larger hydrocarbons tend to undergo incomplete combustion because of the lack of oxygen. So which is why the larger the molecule, the more likely it will have incomplete combustion. Which is why, if you ever notice, candle can make black flames. You know, if you ever put your hand on top of a candle wax burning, you know, that it becomes black. You know, that's soot. But if you do the same thing with methane gas that's on your stove, you never get black smoke, because methane gas is just simply CH4 and it only needs 2 oxygens to become carbon dioxide. So the point is that the larger the hydrocarbon, the more air you need, which is why, by the way, diesel engines are larger than petrol engines. The size of the engine is larger because it needs larger space to intake oxygen gas. So diesel engines are larger than petrol engines, and diesel is more likely to have black smoke. Cars can also have it. There's a chance that even you have less oxygen than this. Now sometimes you might say, well, you might have more oxygen than this but less than that, so it doesn't just become carbon. Sometimes it undergoes more combustion to form carbon monoxide, which is the white sometimes smokes you see, but it's also the poisonous smoke. This fellow can kill you. 27/2 is 13.5. So 6.5 to 13.5 to 18.5. Was it 12.5? Yeah, 13 and 12 is, oh, it's 12.5, not 13.5. Yeah. So sometimes the incomplete combustion. So complete combustion makes carbon dioxide and water. Incomplete combustion forms carbon and carbon monoxide. The problem is you cannot control it. So it's all about how limited you have your oxygen supply. All right. Now you can also do the same for even methane, or let's say the molecule, let's say propane. Propane burning in excess oxygen will make carbon dioxide and water. But if it has limited oxygen, at times it will make carbon monoxide and water, but it has even less oxygen, it will make carbon and water. And if you balance it, 3 plus 4 is 7, right? No, formula is 7, right? So 7/2 is 3, what 7/2 is 3.5. And 3 and 4, that's 2. So you can also, from smaller alkanes, you can also make incomplete combustion. I just wanted to use the larger one first because you guys have probably seen that black smoke, but this is that black fellow. And these two are your incomplete combustion reactions. All right. We're going to end the class here. I hope you had a productive class. Yeah. All right. And I'm gonna head out. Thanks a lot, guys. Peace out. Khuda Hafiz. Khuda Hafiz. I'm glad. I'll see you guys on Thursday, okay? I'll see you on Thursday. Khuda Hafiz.